This video is on, it's an explanation of how to do the problems on the practice test for Chapter 6. Probably the best way to use this is that you have tried to do these problems and you use this as a way to check it. Or maybe you do problem number 1 and then watch the explanation for number 1, then you pause the video and do number 2. That would work. The worst way to use it is to watch the video and write down all the answers, so don't do that. So I kind of abbreviated some of the directions. For 1 to 4, the directions are to graph each inequality, so I just write the directions graph. So we have to graph x is less than or equal to 15, so you have to know the symbol means less than or equal to 15. So it's going to include 15. We can put that on the number line. And anything less than or equal to, so it can include 15, and it goes less than. That's all you have to do, but it's not a bad idea to put another point on there, like put a 0, so you have a point of reference. Number 2 it's a double inequality. It has 2 conditions. X is less than or equal to 25, and x is greater than or equal to 10. So I can read this. X is less than or equal to 25, and x is greater than or equal to 10. Or I could read left to right, saying 10 is less than or equal to x, and x is less than or equal to 25. But it's going to have the points 10 and 25 on it. So 10 and 25. And if I have used this strategy of breaking it down into 2 separate inequalities, you see that I'm going to make it less than or equal to 25. So it's going to go, it can be 25, and it's going to go in this direction. And then I can look at the other condition that it's greater than or equal to 10. So it's going to be 10, can be 10. Sorry about that. It can be 10 and go this way, and it's actually results in a line segment with endpoints at 10 and 25. So when you see this kind of a statement, you'll recognize that you're going to have the graph's going to be a line segment. Number 3 is also a double inequality. It's an or statement, so it's going to have rays going in opposite directions. C is either greater than 11 or it's less than or equal to negative 2. So we're going to have the points 11 and negative 2 on our graph. And we can just break it down and do less than or equal to negative 2 first. So it's going to go this way. It can be negative 2, so we have to put a solid dot there. And it can be greater than 11, and that would go from 11. It can't be 11, so we draw the circle around 11 and go this direction from 11. So that's rays, results in rays going in opposite directions. When you see this or statement, this kind of thing is going to be the result. And then number 4, the number is greater than 15, probably the simplest one that we have actually. So we're just going to put 15 on the number line. It can't be 15, so we circle it and we go in a greater than direction. When you look at the number 5 and 6 have different directions. It's a solve and graph. Solve each compound inequality and graph your solutions. So we have x plus 2 is greater than or equal to 6, or x plus 2 is less than or equal to 5. This looks a lot like number 3, and one of the test-taking strategies is to look for problems on the test that are like ones that you've already done. So the answer to number 5 on the graph is going to look something like what you did for number 3. But we're not really interested in what x plus 2 looks like. We want to know what x looks like. And we can treat this just like it's an equation that says x plus 2 equals 6. We have to get x by itself, so we're going to subtract 2 from both sides. I'm going to change the white there. And subtract 2 from 6. There's a 0 pair, so that would disappear, leaving x is greater than or equal to 4, which looks good. We can graph that. Subtract 2 here, and we get x is less than or equal to 3. And this is an or statement. So these are the conditions that we want to graph, that x is greater than 4 or equal to 4, or it could be less than or equal to 3. So on the graph, we're going to put a 4 and a 3. And we're just going to graph each of these. X can be greater than or equal to 4. So we're going to put the solid dot and go this direction. Or x can be less than or equal to 3. So dot it and go less than. So that's what the solution to the number 5 would look like. Number 6 is a problem that looks like number 2. But we don't want to know what x minus 1 is less than or greater than compared to. We want to know what x is. So we have to undo subtracting 1. And the way you do that is to add 1. And you add it here. And you're going to add it here and here. So we have to do it 2 more times. Plus 1, plus 1. And the resulting statement will still be true. 20, and this is a 0 pair, is less than or equal to x, and x is less than or equal to 32. So now we have the graph that's much simpler to understand. We have to make x be less than or equal to 32. So it can be 32, and it's going to head this direction. And 20 is our other endpoint. And 20 is less than or equal to x, and we can make a little bit more sense of that if we read it in this direction. X is greater than or equal to 20, so it's going to go this way. And if you look back at your answer to number 2, it's a line segment like this. It also includes a 20, so make sure I put that endpoint in there. There's number 6. For number 6, I didn't write the whole problem down, but 6 and 7, the directions are to graph on a number line. So there's a situation that's described, and you have to represent that on a number line. The minimum wage for a 12-year-old is $6, and the maximum wage is $12 per hour. Minimum means the smallest that you can have, so the least amount you can make is $6. But it can be $6. It can be $6, so we're going to include that. But it could be more. It can head off in this direction, but there's a stopping point. The maximum is $12. But you can get $12, but you just can't go any higher than that. So this would be what the words, the minimum wage for a 12-year-old is $6 and the maximum wage is $12 per hour, could be interpreted and put onto a number line. So this is the solution to number 7. Number 8, children under 12 are admitted free. So, if you're 12 years old, you don't get in free because you're not under 12. So we go here, and we go this direction. But you have to think logically about this. We're not going to go, it's not going to be an array because, I don't know whether you would put a 1 or a 0, go ahead and put a 0, but there's a place here where, you can't be negative years old. So it would look like this. And I don't know this is a very interesting thing to think about, whether you want to put a dot or a circle there. If you put a dot, that means you're 0 minutes, seconds, years old. I think maybe a circle makes more sense here. But I probably would accept either on that. The main thing I want to see here is that you get this under 12 part. So that's number 8. 9 to 11 of the directions are to write an inequality for each graph. Sorry, I kind of messed. Let's copy the problem. So I just start over again, and I can't really erase that, so I just kind of scribbled over it. Don't let that happen to you. So we have to interpret what we see here. So we're going to say, you can pick a variable. You could be x or n. I'll use n on this one. It's a pretty simple one. The number is less than, but not equal to -4. So this would be the correct response to number 9, because the number can't be -4. The circle says it can't be 4, and it goes less than. In number 10, you see something that should remind you of number 3 and number 5, which is a big hint about how to figure it out, because it should look like number 3 is an OR statement. So if we use the letter X, we'll say that X is less than, but can't equal, -3, or X is greater than and can be equal to 6. So we just break it down and write something that describes this, then write something that describes this, and it can be either one, but it just can't be the space in the middle. It can't be anything in between here. So this is the correct response to number 10. X is less than -3, or X is greater than -6. Number 11 should look a lot like what your number 2 should look a lot like what you see at number 11, because it's an AND statement, a line segment results. And it's a number that is between -10 and 20, positive 20. It can include negative 10, but it cannot include positive 20. So we can start by just pick the letter, say n, and you can go either direction here. You could say that it is greater than or equal to negative 10. Or you could have said, I'm going to have two answers here, that it's less than 20. But if I pick option number 1, where I use this symbol, I have to repeat that symbol here. So the number is less than 20. 20 is greater than the number, and you can see that's true. Then here we have a 20, and it's greater than any of these things. If I picked this option, where I would use the less than symbol, then I'm going to use a symbol like that, but this can include negative 10, so I have to make it less than or equal to negative 10. So I can read this two different ways. I can read this as negative 10 is less or equal to the number, and the number is less than 20. Or I could read it, the number is less than 20, and the number is greater than negative 10. And I can read this one as the number is greater than or equal to negative 10, and the number is less than 20. Or I could read it as 20 is greater than the number, and the number is greater than or equal to negative 10. Now, either of these two is the correct solution to number 11. Pick the one that makes the most sense to you. 12 and 13 are two-step equations. Solve for the variable and show your work. There is plenty of space for you to show your work on your paper. Even if you do it on a whiteboard, please show your work on your paper. So I can't really show this very well, but one of our strategies was to cover up the term that has the variable in it. So you can imagine that's just not there. You would see plus 8, which tells you the first thing you have to undo is add 8, and you do that by doing the opposite, which is subtract 8. I'm going to switch over to white there, sorry. And then you have to do the same thing on the other side. The subtraction property of equality, whatever you do to one side, you have to do to the other. That's a zero pair. So 3n, and you have to be accurate on your arithmetic. 17 minus 8 is 9. So you've undone part of it, but it's a two-step process. Now you have to undo multiplying by 3, and it's very easy to show by do the division bar. And then you could say this would be 1n, and the arithmetic is 9 divided by 3, and that's 3. So there's the answer. And you go back up and say 3 times 3 is 9. 9 plus 8 is 17. Just make sure that your answer makes sense. In this equation, we start with a number, double it, subtract 16, and end up at negative 2. So you have to work backwards. The last thing you would have done is subtract 16. That's the first thing you have to undo. Again, you can think about cover up the term with the variable, and what you would see is subtract 16. The opposite is add 16. Put it right under the subtract 16. Don't put it under the 2n, and add 16 to negative 2. We bring this equation, this equal symbol has to stay in here all the way through. So we have the left side and the right side. Maintain that left, right, and equal symbol. This is a zero pair. We're left with 2n. 16 positives and 2 negatives. The net is 14 positives. And we undo multiplying by dividing. That's 1n, 1 over 1 is 1. 14 divided by 2 is 7. So we would say 2 times 7 minus 16. If you simplify that, you would do 14 minus 16, and that does indeed equal negative 2. So that's a good solid answer. In number 14, you have to write an inequality, both 14 and 15. You don't have to do a number line on this one, but if it helps you to do a number line to understand what this might look like, you could. You put, it's between negative 5 and positive 12. It can't include them. So it would look like this. This might help you just because then you can see that your answer looks like something to number 11, looks like something at number 2. especially number 2, which is in the form that you have to create. Number 2, which says 10 is less than or equal to x, and x is less than or equal to 25, will look a lot like this one. So we're going to say, pick a letter, and perhaps it has to be less than 12. That gets this part of it. Less than 12. And we have to use the same symbol. It's not going to include -5, but it's greater than -5. So this is exactly what we're looking for. This is writing an inequality given a verbal description, or given, well, it's actually not verbal, it's a written description using words, and you have to translate that into algebraic symbols. So number 15 is probably a level easier than number 14. A number is greater than or equal to 20. So we just say the number is greater than or equal to 20. It's that easy. I wouldn't even, you could draw it on a graph. It would look like this, but 20 in, it can be 20 and it goes this direction. But you probably don't need to draw a number line to help you understand that, but if it helps you, go for it. For 16, 17, and 18, you're going to write yes or no. It's like true or false. Given that 5 times a number is greater than or equal to 30, is that true if the number is 4, and it means this number right here, that, n, not the 5, the n. 5 times n, where n is 4. So just grind it out and get it right. You just say, is it true that 5 times 4 is greater than or equal to 30? You do the arithmetic over here. Is it true that 20 is greater than or equal to 30? And you use your logical reasoning. No, 20 is not greater than or equal to 30. The answer number 16 is no. If x is -10, is 3 times x plus 15 greater than or equal to 9? You just put it in there and say, is 3, I'm going to use parentheses here, times -10 plus 15 greater than or equal to 9? You have some space on your, there's not much space underneath these items, but you have plenty of space over to the right on your practice test to show this work. Then you use order of operations. We do multiplication before we do addition. 3 times -10 is -30 plus 15. Still don't know yet. 30 negatives and 15 positives is a net of 15 negatives. Is that greater than or equal to 9? Is -15 greater than or equal to 9? Again, it's a no. 200 plus y is less than or equal to 1500. There are certainly some values for y that would make that true. Is -1 one of those? 2000 plus -1, put that in parentheses to separate the addition symbol from the negative sign. Less than or equal to 1500. 2,000 positives and 1 negative leaves 1,999 positives, which is not less than or equal to 1500. But beware. Just because everything on the practice test was no does not mean that everything on the real test is no. Probably not. You'll just have to do each one of them individually and figure it out. Okay, in the last part, 19, 20, 21, you have word problems, write an equation or an inequality or a compound inequality, solve it and check it. So you read the problem, which I didn't write them all down. You have them in front of you, hopefully. I'll read them here. And then we pick a variable to stand for the unknown, and we write something using an equation or an inequality or compound inequality and solve it. Kevin has to raise at least $4,000 for a missions trip to Haiti. He currently has $2,500. How many more donors does he need if each one gives him $75? So we need to figure out the donors. D. That stands for donors. And let's think about how much money he raises for every donor. $75. So if he has 2 donors, he has 75 times 2. 3 donors would be $75 times 3 donors. D donors must be 75 times D. That's the amount of money that he raises. and he needs at least $4,000. But he can get more than that. But he has to have at least 4,000. He's already got 2,500. So if you take the amount that he's going to get, that he anticipates from the amount that he's going to raise, and you add the 2,500 that he already has, that's how much he will have. And that has to be greater than or equal to $4,000. And I have totally run out of space here, but what we would do is subtract. Maybe I'll move this up. Yep, that's good. Can do that. We're going to subtract 2,500 from each side. We're solving this just like it's an equation. That would leave 1,500 here. This is a 0, which is what we wanted. 75D. Maintain that symbol. It was a greater than or equal to. Divide both sides by 75. I'll just take the time to do this down here. It's going to be, I can see what the answer is going to be. 75 doesn't go into 1 or 15, but it goes into 152 times evenly. So D has to be 20. Actually, I should say it's greater than or equal to 20. If he gets 20, he has enough money, but if he gets 21, he has an extra $75, and that's okay. He has to have at least 4,000, but he can have more. So it was important that that symbol maintain be the same all the way through solving this inequality. And number 20 reads, the product of 5 and a number is either less than 50 or more than 60. What could the number be? And it's a compound inequality. So the number, let n be the number. So the product of 5 and the number is 5n. And it's either less than 50 or 5n can be greater than 60. That's the hard part, is translating the words of the problem into an inequality. Then we can divide both sides by 5. I can do the same thing here. I should put the word or here, because the product of the number is either less than 50 or it's greater than 60. So when I divide 5 into 5, I get 1 over 1. 5 goes into 50 10 times. So this side would be the same as the number is less than 10. Or, again, do the same thing here. 5 goes into 5 1 time each there, and 5 goes into 60 12 times. And you might just have to work that out on the side. So this would be saying that the number is greater than 12. And that's the solution, that n is either less than 10 or it's greater than 12. So it can't be the things in between. It can basically be anything except in between 10 and 12, including 10 and 12. So you're fortunate enough to get a summer job which pays $12 an hour, and you want to earn at least $2,000. How many hours do you have to work? Well, let H be your hours. And think of how you're going to represent how much money you make, because you get $12 for every hour. If you work 2 hours, it's 12 times 2. If you work 10 hours, you make 12 times 10. You basically can get 12 times the number of hours. And remember, 12H means 12 times H. This is the amount that you earn in the summertime. That summer, you would earn 12H. And you want it to be at least $2,000. 12H is at least, so it can equal, but it's okay if it's more. So we're going to say greater than or equal to 2,000. So there's our hard part. Now the easy part's divide by 12. And I have a hunch this is not going to come out to be a nice, wonderful whole number. So we have to divide both sides by 12 to find out what H equals. 12 divided into 2,000. I'll put a dot, and this would be dollars and cents. 12 goes into 20 one time, remainder 8. 12 goes into 80 6 times. 6 times 12, 72. Remainder 8. Okay, so we can see what's going to happen here. 12 goes into 80 6 times again. And it's just going to be 0.66. Repeating. So the best way to do that might be to say it's 166 and 8/12 hours, which would be 166 and 2/3. Or I'm looking at, the problem doesn't say rounded to the nearest hour, but if it did, it would be 167 hours. So that would, either of these, that would be a solution. You could write it this way or this way. So there's number 21, and that's the way the test goes.